For over 50 years, humans have ventured into space, seeking to understand the very building blocks of life. Rovers have been sent to explore the surface of Mars, drilling into its red soil, in search of evidence of ancient water. Probes have explored Venus, delving into its dense, sulfuric clouds to learn more about its atmosphere. Samples from distant asteroids have been collected, revealing clues about the early solar system. Despite these incredible efforts, the search for life beyond Earth, the essence of life, has remained just out of reach. Now, the next great leap in this quest is ready to launch aboard the Falcon Heavy rocket. On board is the Europa Clipper mission, destined to explore one of the most enigmatic worlds in our solar system, the icy moon Europa. Europa may seem an unlikely candidate for life at first glance. It orbits Jupiter, far beyond the Sun's habitable zone, subjected to extreme gravitational forces that create intense conditions. Europa, slightly smaller than Earth's moon, lacks a thick atmosphere or a magnetic field to protect it from radiation. The surface of Europa is harsh, exposed to high levels of radiation, making it a frozen, barren landscape. With no sunlight and radiation levels high enough to damage electronics in hours, Europa initially seems inhospitable. Yet, despite these challenges, Europa has become one of the most intriguing places to search for life. Evidence suggests that beneath Europa's icy surface lies a vast, hidden ocean. This subsurface ocean could potentially offer a suitable environment for life, sparking the imagination of scientists and fueling the Europa Clipper mission. Europa's mystery began with the Voyager spacecraft in the 1970s, which sent back the first images of the moon's smooth, ice-covered surface. Unlike other moons of Jupiter, Europa's surface features long ridges and cracks, hinting that its ice may shift and reform over time. Follow-up observations by the Galileo spacecraft revealed even more intriguing details. Signs of potential tectonic activity were discovered beneath the surface, hinting at a dynamic world below. However, the mission faced obstacles. Galileo had to endure Jupiter's intense radiation belts, which caused damage to its instruments. Despite these setbacks, the data it collected showed a tantalizing possibility. Europa may be hiding a water-rich world beneath its surface. Europa's extreme radiation, while hostile to life on the surface, might actually be key to its potential for life. Charged particles from Jupiter's powerful magnetosphere strike Europa's icy surface, creating chemical oxidants like hydrogen peroxide. These oxidants, if they seep into Europa's ocean, could trigger chemical reactions that support life, a fascinating possibility for astrobiology. Europa's proximity to Jupiter provides more than just a stunning backdrop, it offers the energy that might make life possible. Europa's orbit around Jupiter is highly elliptical, which stretches and compresses the moon, creating internal friction. This tidal flexing generates heat beneath Europa's surface, possibly keeping its ocean warm and liquid. The key to confirming Europa's hidden ocean lies in its magnetic field. Galileo's spacecraft detected unexpected disturbances in the moon's magnetic field, suggesting something more than just a small iron core. This disturbance pointed to an electrically conductive ocean beneath the ice, a breakthrough in our understanding. In 2014, the Hubble Space Telescope provided further evidence, detecting massive plumes of water vapor erupting from Europa's surface. These plumes contain salt and other chemicals from Europa's ocean, directly linking the surface to the hidden world below. The Europa Clipper mission will now undertake the task of exploring these mysteries.
How thick is Europa's icy shell? How does it shield the ocean from Jupiter's radiation? Europa Clipper will attempt to solve these mysteries with its detailed approach. Originally set to launch on NASA's Space Launch System, SLS, the mission was ultimately moved to the Falcon Heavy rocket. This change made the mission more cost-effective, though it also extended the journey to Jupiter. The spacecraft will use gravity assists from Earth and Mars to slingshot toward its destination, taking a longer route but making the mission feasible. Once it reaches Europa, Clipper will face the challenge of navigating Jupiter's intense radiation belts. A direct orbit around Europa would expose the spacecraft to fatal radiation levels, so it will follow an elliptical orbit around Jupiter. By passing close to Europa every 14 days, the spacecraft will collect crucial data while avoiding excessive radiation exposure. Each close encounter will allow Clipper to gather a wealth of information before retreating to safety. To protect its electronics, Clipper is equipped with a special aluminium vault. This shield is only 1 centimeter thick but carefully designed to protect sensitive instruments while keeping the spacecraft lightweight. The spacecraft's instruments are arranged inside the vault, ensuring maximum protection while retaining full functionality. One of Clipper's most exciting tasks is to analyze Europa's magnetic field in great detail. Equipped with 3 highly sensitive magnetometers, the spacecraft will measure the magnetic field from different directions. These sensors are mounted on a lightweight carbon fiber boom that extends and deploys without the need for complex mechanical parts. This design will allow for the most accurate measurements of Europa's magnetic environment ever taken. Clipper's primary mission is to gather direct evidence of Europa's ocean, which it will attempt to do by flying through the water plumes. Using a specialized collector, Clipper will capture particles from the plumes and analyze their composition. By studying these particles, scientists will gain insights into the building blocks of life. If Clipper doesn't pass through a plume, it will still analyze Europa's atmosphere for gases produced by radiation interactions. Using electron bombardment, the spacecraft will ionize these gases and analyze their composition. Finally, Clipper will use advanced radar systems to study Europa's icy shell. By measuring its thickness and searching for signs of subsurface activity, Clipper will gain a deeper understanding of Europa's internal structure. Europa Clipper's solar panels, each stretching 30 meters in length, make it one of the largest solar-powered spacecraft ever sent into deep space. This innovative design marks a shift from previous missions that relied on nuclear power. The success of missions like Juno and Rosetta, which also used solar power, has proven its effectiveness even in the far reaches of the solar system. Ultimately, the Europa Clipper mission will provide a wealth of information about this captivating moon. With each close encounter, the spacecraft will send back stunning images and vital data, moving us closer to answering one of humanity's most profound questions: is there life beyond Earth? Ultimately, the Europa Clipper mission promises to provide groundbreaking data that will help answer one of humanity's most profound questions: could there be life beyond Earth? As Clipper continues its journey toward Europa, the scientific community eagerly awaits the wealth of information it will deliver, which may bring us one step closer to understanding the possibilities of life elsewhere in our